Okay, so we are going to finish off this semester by looking at how we're going to graph the quadratic function. And we're going to do that using two different forms. Today is going to be an introduction into what the quadratic function looks like. All right, it is called a parabola. It's a U-shaped curve. And then we're going to work today about developing some skills so that ultimately we can discuss the vertex form of a quadratic, which is something you haven't seen yet. And then we're going to use that to graph tomorrow. All right, so again, this is all about understanding what the graph of a parabola looks like and then moving it around, so shifting it up, down, left, and right, and then ultimately leading to what is vertex form and how we're going to use that. All right, so if you look at this slide here, it's first just kind of shows you the values that you plug in, -2, -1, 0, 1, and 2. You can plug in obviously any values you want. All right, but in this case, those are the kind of the main ones we're going to plug in so we can see what it looks like. So this right here is the graph of the quadratic function. All right, you spent a ton of time as freshmen and then even again as sophomores or juniors looking at the linear parent function, so that's a line. Again, this quadratic is something we're going to look at a lot over the next few weeks. All right, now we're going to shift them, as I said, up, down, left, and right. And I know it looks a little confusing, but hopefully with our work that we did a few months ago with absolute value functions, where we moved those up, down, left, and right, and that was our V, if you recall. All right, so we moved those up, down, left, and right, and it's going to be very similar to when we did that a few months back, okay? So the main thing to focus on here is that the horizontal shift is x minus h, and that's inside the parentheses. So again, just like we did with absolute value functions, we're going to think opposite when we shift to the left or to the right, so horizontally. When we do vertical translations, it says plus k, and it's on the outside, so that's going to shift up and down just like you would think, positive up, negative down. All right, so let's look at graphing the parent function. So off to the side on your slides, go ahead and make a table of values here. So we have x, and then we'll do f of x, which is, the same way as, just a fancy way of saying y. And we're going to plug in, as I said, those values -2, -1, 0, 1, and 2. All right, so the idea being that these, all 5 of these, are being plugged into f of x equals x squared. So if I square all these numbers, keep in mind to put all these in parentheses, I will get positive numbers for all 5 of these. I guess 0 not positive, but you get the idea. So big thing here is they all become positive even when you plug in a negative. So if I were to plot those, 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. This is our basic parent parabola. All right, so it looks like a U-shaped curve. All right, so that is the parabola. So get used to graphing that. We're going to graph that a lot over the next couple of weeks. And so these are the values that we plugged in, -2, -1, 0, 1, and 2. Now, for the first part of today, I just want to focus, okay, if I add some numbers in here, how is that going to shift what I just graphed? So I'm going to use green for this one, that's g of x. So again, if I look inside the parentheses, I have +3. So inside parentheses, you should be thinking horizontally, which is left or right. Now, a lot of students, when they see that positive, they think, okay, positive, I'm going to move to the right. But again, you have to think opposite. So this is actually going to be 3 to the left. 3 to the left. All right, the number on the outside is a +1. That moves the way that you would expect. That's a vertical shift, 1 up. All right, so all I'm going to do is move every single point that I plotted here, all 5 of these black points, move them 3 left and 1 up. So 3 left and 1 up. All right, and I have my new parabola. Again, it should look exactly the same as the original function. The only thing that's happened is I have shifted it left and up. All right, so I'll give you a few seconds to kind of make sure you have all of that. Big thing on this is inside the parentheses, you must think opposite. So a +3 in the parentheses is actually 3 to the left. All right, I'm going to use blue for the next one here. I have a -2 inside the parentheses and a -1 outside. So if on the previous problem, moving 3 to the left was a +3, If I look inside the parentheses, I see subtraction of 2. So it's actually going to be 2 to the right. And then minus 1 on the outside is 1 down. All right? So I'm going to go back to the original, my 5 black points, and move them 2 to the right and 1 down. So 2 to the right and 1 down. And there is my new function. Again, if I did this correctly, it should look no different. So all 3 of these should look exactly the same. All right, all I've done is shifted them up, down, left, or right. So we did this, as I said, we did this with absolute value functions, those v's, back with chapter 2. So this is the same idea, except we're using the quadratic function here, the parabola. All right, so now what I'm going to do is I'm going to ask you guys, all right, to try some on your own. Now, I just want you to sketch. When I say to graph, I just mean to sketch. So this really just means, just want you to sketch. So for example, if you were to do, if I wanted you to sketch this one in green, all I'd want you to do on the one in green is you graph the original, and then you sketch it 3 left and 1 up. So 3 left, 1 up, and then you do it. So you don't need to, it doesn't need to be precise. I just want you to sketch after you say how the parabola is moving. Okay, so again, on 1, 2, 3, and 4, say how is it moving up, down, left, to right, and then sketch the original. So that's f of x equals x squared, and then just sketch how you would move it. All right, that's it. All right, so go ahead and stand up and move to your boards.